Welcome to the New Mexico 911 Program GIS Training video series. This video in the series provides an overview on the NM911 GIS data assessment process. To give you a quick background, the New Mexico 911 program is managed by the New Mexico Department of Finance and Administration, referred as NMDFA. Starting January 2019, NMDFA contracted with the Earth Data Analysis Center, EDAC, at the University of New Mexico and Bohannon Houston Inc., BHI, to provide GIS data services to the program. EDAC's role include data acquisition, processing, assessment, reporting, and providing technical support to the GIS data providers in the state and creating a statewide NM911 master database, whereas BHI's role involves in generating data clips from the statewide master database and working with the PSAPs to update their map servers for emergency response. There are 84 GIS data providers, referred as geodata providers by the NM911 program, which include counties, cities, towns, villages, and tribes. And there are 41 public safety answering points or 911 call centers in the state. Among those, 34 are managed by the local entities such as counties and cities, 4 are tribal PSAPs, and 3 are managed by the New Mexico Department of Public Safety or DPS. And these PSAPs use 5 different mapping systems in the state. They are Airbus Mapstar, Airbus Vesta, Motorola CallWorks, West Mapplex, and West PowerMap. The NM911 program adopted a GIS data model to normalize data collected from the geodata providers using a standard schema. The version 1.0 requires 3 mandatory GIS data layers from the providers. They are road center lines, address points, and administrative or addressing boundaries. To standardize boundary across various providers, the NM911 program uses county boundaries from the U.S. Census Bureau and NM incorporated boundary data from the New Mexico Taxation and Revenue Department for administrative boundaries, unless a separate addressing boundary is provided by the geodata provider. The model also includes optional layers such as emergency service zone boundaries and PSAP boundaries, and these data are required for next generation 911 systems, and NM911 program encourage geodata providers to submit these data if they are available. The New Mexico 911 program worked with the geodata providers to update existing schema to include additional data layers required for the next generation 911 compliancy and created a new data model, version 2.0. This database schema is adopted in September 2019, which includes minor modifications to the existing layers and includes new layers such as public facilities, community boundary, hydrology, railroads, mile markers, and bridges. Database schema, spreadsheet, and the GIS data model geodatabase formats can be downloaded from the NM911 website at nm911.org. This is the EDAC GIS workflow. EDAC's workflow includes data collection, conversion, assessment, reporting, and creation of master database. Beginning of each month, an email notification will be sent to geodata providers for data collection. The timeline for the collection is from 1st till the 15th of each month, and data must be uploaded to the NM911 data portal. The uploaded data are then converted from local schema to state schema using a crosswalk tool built into the data portal. The next step is data assessment. This involves performing spatial and tabular accuracy checks, topology checks, data reviewer checks on the data uploaded, and any additional data analyses that are required by the program. Once the assessment is complete, a report and an error geodatabase are generated and are made available on the NM911 data portal for the geodata providers review. They are notified via an email when these are ready. These data are then aggregated to create a statewide master database, which is then delivered to BHI for PSAP map updates. In addition, these data are made available as shapefiles on ArcGIS Data Clearinghouse for public access. This is BHI's GIS workflow. After BHI received the master database from EDAC, they transform these data to match PSAP map formats. BHI then prepares individual data clips for each of the PSAP based on their boundaries. These data are then distributed to PSAPs. BHI documents the status of the data updates and notifies PSAPs and the procuring agency. BHI documents the status of the data updates and notifies PSAPs and the procuring agency when the data transfer is complete each month. In addition, EDAC and BHI works together if there are any data issues at PSAP end. These data issues will be then reported to geodata providers for their review and correction. Let's take a closer look at EDAC's workflow. Data collection. The data are collected through a secure NM911 data portal, and the timeline is 1st till 15th of each month, and the accepted formats are shapefiles and file geodatabases. The assessment checks are performed to ensure data integrity and accuracy of the three required data sets: address points, road center lines, and the boundaries. EDAC performs spatial and tabular accuracy checks to ensure the records have valid geometry and data values in the attribute fields. In addition, EDAC performs topology and data reviewer checks to ensure the spatial and attribute relationships are maintained in the data. The image on the right shows the various topology checks that were implemented in the current validation procedures for the three required data layers. These checks will be expanded to include additional data layers such as ESZ and PSAP boundaries in the near future. There are about 20 different data reviewer checks that are performed on the data, which include 6 checks on the address point data and 14 road centerline checks. In addition to the data assessment, the NM911 program performs data analysis on the geodata provider's data and generates fishbone lines. These lines represent a straight line comparison between 2 points, the address point locations that are provided by the geodata provider and their respective geocoded locations. These are geocoded using the road centerline data provided by the provider. The fishbone lines provide a visual comparison to identify inaccuracies in the data. These include if the address points that are out of numerical order or if they are on the wrong side of the street or on the wrong block. Here are a couple of examples of address points that were placed correctly. These are a couple of examples with inaccuracies in the address point data identified by fishbone lines. The image on the left shows how addresses are incorrectly assigned where the address numbers do not fall within the road centerline address range. The image on the right hand side shows an issue with the parity, where the left address ranges are odd and the right address ranges are even. Fishbone analysis also identifies points with incorrect addresses or no addresses. As part of the data reporting tasks, EDAC generates an assessment report and error geodatabase each month for the data uploaded. The error geodatabase includes 3 feature datasets. One for Fishbone analysis. It is a conditional dataset only generated if the addresses and the roads uploaded by the geodata providers include postal community names and the zip codes. NM911 feature dataset includes feature classes with the state schema. NM911 errors feature dataset includes feature classes based on various error checks. The name of the featured class shows the error type. Data providers can add these feature classes to their ArcMap to view the errors and correct them in their GIS data. Working with geodata providers, we have noticed that not all errors that were caught by the software are actual errors on the ground, or certain things can be changed, such as readdressing houses. In those cases, we allow exceptions in the data. Here are a few error checks where exceptions are allowed, where left address ranges must be odd and right address ranges must be even, or if low address is greater than the high address on the left and right side of the road center lines. In these cases, records can be marked as an exception. There is a column CI exception or C1 exception in the legacy data, and we continue to use that column. In the NM911 GIS Data Model 2.0, we have renamed the column as simply exception. If the geodata providers are using MapSag software, the software itself assigns an exception code. If the providers are not using MapSag, we recommend marking Y or 1 in the column based on the data type of the column. Here are a couple of examples of topology errors where roads must not intersect or touch interior. These can be fixed by breaking the road center line at the intersections and snapping them properly, with an exception of overpasses and underpasses. And address point must be properly inside the administrative boundary. These issues can be corrected by providing an addressing boundary for validation if available. Here are a couple of examples for address point checks, where on the left hand image that shows address point address number cannot be 0. In the tables down below, you can see that the address number is 01 Perea Road, whereas the range for the road center line starts from 700 till 999. And similarly, on the right hand side, the address point address number should be within the road center line address range. If you look at the road ranges for the Hillside Drive Southwest, it starts from 1659 and ends at 1700, where the address is 922 Hillside Drive Southwest. And a couple of road center line examples. On the left hand side, address point full road name must match road center line full road name. If you look at this post direction for that address point, it says 1524 Via Vista Road NM instead of Northwest. So this needs to be corrected. And on the right hand side, where road center line must not have right side overlapping address range, and if you look at the address ranges for those road center lines, you can see an overlap. Once the assessment is complete, EDAC aggregates data from various providers into a state master database, runs geometry checks to make sure there are no invalid data that might have made it into the database during this process. Once the database is ready, it is delivered to BHI and are also made available as shapefiles on the ArcGIS Data Clearinghouse. For technical support, please contact Earth Data Analysis Center, and for general program inquiries, reach out to Mr. George Clark at the New Mexico Department of Information Technology. This concludes NM911 GIS Data Assessment Overview video. Thank you for your time and attention. For more videos, check the NM911 program website at nm911.org.